Hello there, and welcome to Deep Space Sleep. I'm really glad you're here, settling into this quiet moment. Long before continents took their familiar shapes, and long before oceans found their calm blue rhythms, the Earth was a world of slow fire. Under the crust, heat moved like a gentle pulse, rising and falling in patterns older than life itself. Volcanoes were not explosions in the way we imagine them today. They were the earliest breaths of a young planet, releasing warmth into the sky and shaping the land with movements so patient they felt like time itself learning to flow. As the world cooled, these fires didn't disappear. They simply quieted, turning into the hidden chambers of warmth beneath mountains, oceans, and forests. Even now, beneath the ground we walk on, magma drifts slowly like glowing honey, shifting in silence. And when a volcano does rise, or breathe steam, or let out a small whisper of gas, it does so following rhythms that have been repeating for billions of years. There is nothing hurried about it. Even fire moves slowly when it belongs to the earth. In this calm space, we're going to explore the softer side of volcanoes, the subtle signals, the quiet flows, the peaceful shapes, and the gentle landscapes that form long after the fire has cooled. You'll hear about magma traveling like a slow river, ash drifting like fine snow, and entire islands rising from the sea as quietly as a dream forming in the dark. If you'd like, you can share where you're listening from and what time it is for you right now. People around the world drift into sleep or into rest through these videos, and your presence helps weave a sense of calm community among everyone listening under the same shared planet. For now, let your shoulders loosen, let your breath fall into a slower rhythm, and let the quiet warmth of the earth guide you gently inward. Let's begin. Volcanoes act as natural pathways for the Earth's heat, allowing warmth from deep within the planet to slowly rise toward the surface. Instead of imagining them as sudden bursts of fire, picture them as gentle valves that help the Earth release energy built up over millions of years. Beneath the crust, heat moves upward in quiet pulses, and volcanoes simply provide openings where that heat can escape. This process shapes the landscape patiently, forming mountains, islands, and plains over timescales far longer than any human lifetime, even when they are completely still on the surface. These volcanic pathways continue to balance the inner warmth of the planet with the coolness of the outer atmosphere, creating a calm, slow-moving exchange that has been happening since the Earth first cooled. Deep beneath the ground, magma flows with a softness that feels almost alive, moving at a pace as slow and steady as a heartbeat. Rather than rushing or boiling violently, magma often drifts through underground chambers like glowing syrup, spreading its warmth quietly through cracks and layers of rock. This slow movement helps shape the Earth from within, guiding the formation of new crust while recycling old material back into the planet's interior. Even when it does rise toward the surface, magma maintains this patient rhythm, taking its time to build pressure, find pathways, and follow gravity's gentle pull. The Earth's internal heat moves with calm intention, creating a rhythm that mirrors the deep, steady pulse of the planet itself. The heat beneath our feet has been there since the Earth first formed over 4 billion years ago. When the young planet was still glowing and molten, its interior stored enormous amounts of energy, and that warmth continues to radiate outward in slow, steady waves. This ancient heat comes from the leftover energy of Earth's birth, from the constant decay of radioactive elements and from the slow, gentle stirring of materials deep in the mantle. Even now, the planet cools only inch by inch, releasing its warmth so gradually that millions of years feel like a single soft exhale. This quiet, persistent heat is what drives volcanic activity, shapes continents, and keeps the Earth geologically alive. Most volcanoes spend the majority of their existence in deep, peaceful silence. They rest for centuries or even millennia, barely releasing a whisper of gas or a trace of heat. Their long periods of inactivity are not signs of dormancy in the dramatic sense, but expressions of the planet's unhurried rhythm. During these quiet eras, their slopes gather forests, lakes form in their craters, and wildlife settles into the calm landscapes shaped by old eruptions. These resting volcanoes are reminders that geological time moves slowly, that the Earth's forces rarely act with haste, and that even giants of fire spend most of their lives simply breathing softly beneath the sky. Far below the surface, rocks expand when heated, creating pressure so gentle and gradual that it can take thousands of years to build. This expansion pushes against surrounding layers, loosening grains, widening tiny cracks, and preparing pathways for magma without making any sound. The process is delicate, almost like the Earth stretching quietly from within. Over long periods, these subtle changes accumulate, guiding the slow upward movement of heat and molten rock. The pressure does not rush or strain, it simply grows in harmony with the planet's internal warmth, shaping the deep foundation of volcanoes long before any visible activity appears. Before an eruption ever becomes visible, the first hints often appear as the softest possible release of gas escaping from small openings in the ground. These gas emissions rise gently, almost like warm breaths exhaled by the Earth, carrying faint traces of water vapor, carbon dioxide, and sulfur that drift upward without force or sound. The movement is so subtle that it often goes unnoticed, blending into the air like mist rising from warm soil after rain. These early whispers are part of the planet's natural rhythm, spreading warmth from deep magma chambers into the cooler world above. The gas does not rush or burst, it simply drifts and disperses, giving scientists and sensitive instruments the earliest signs of change far below. This delicate release reflects the slow patience of volcanic systems, which rarely leap into activity without first breathing out these quiet, barely noticeable signals from within. Across the planet, more than 1,300 volcanoes are considered active, yet almost all of them rest in long, peaceful stillness. They spend centuries or even millennia without producing an eruption, standing as quiet mountains wrapped in forests, snow, or ocean mist. These sleeping volcanoes carry the memory of ancient fire, but today they feel more like guardians of the landscape than threats. Their slopes are home to wildlife, rivers, and even entire communities that grow around them without sensing any urgency. Beneath the surface, their magma systems cool slowly, shift gradually, and breathe in deep geological time. Far removed from the pace of human life, these quiet giants remind us that Earth's internal forces work with incredible patience, choosing stillness far more often than motion, and resting so deeply that the world above can forget the fire quietly waiting beneath. Many volcanoes are hidden far beneath the ocean's surface, forming underwater mountains that rise slowly from the seafloor. These submarine volcanoes shape the world in secret, building ridges, islands, and plateaus in complete darkness, surrounded by the deep, cold pressure of the ocean. Their activity is softened, muted, and almost completely silent. When lava erupts underwater, it cools instantly, turning into smooth pillows of volcanic glass that stack gently upon each other like layers of rounded stone. These hidden volcanoes create new crust, support ecosystems of rare life forms, and influence the chemistry of the oceans without ever revealing themselves at the surface. Their presence is a quiet reminder that most of Earth's volcanic activity happens out of sight, deep below where light cannot reach, and that the planet's inner warmth touches even the darkest places through slow, patient geological work. Magma, deep inside the Earth, often contains water that has been trapped for millions or even billions of years. Originally drawn down from ancient oceans during subduction of tectonic plates, this water becomes part of the molten rock, dissolved under immense pressure and heat, giving magma a unique softness and fluidity that helps it rise. When this water-rich magma moves upward, it carries with it the memory of long-vanished seas, blending the planet's deep interior with its ancient surface. As it cools or decompresses, the dissolved water begins to separate out as bubbles, creating gentle pressure changes that influence the texture and behavior of eruptions. This hidden connection between magma and ancient oceans shows how Earth continuously recycles its own history, pulling old water downward and slowly returning it upward through the planet's deep, glowing pathways in a cycle that spans geological ages. Tectonic plate movement is the primary force behind most volcanic activity, guiding the planet's internal heat toward the surface with movements so slow they are almost impossible to sense. These plates drift only a few centimeters per year, yet over millions of years they reshape continents, open oceans, and create the deep fractures where magma can rise. When plates pull apart, molten rock fills the gaps. When they collide, one plate sinks beneath another, carrying heat and water into the mantle, where new magma forms quietly. Even hotspots, far from plate boundaries, are influenced by the mantle's gentle convection currents driven by plate motion. These slow, steady movements act like the Earth's heartbeat, setting the rhythm for volcanic creation across the globe. Despite their power, the plates move with patient calm, shaping the planet in soft, gradual motions that unfold over enormous spans of time. Magma moves beneath the Earth with the quiet slowness of warm wax drifting under soft light. Instead of rushing through the crust, it flows through underground chambers and narrow pathways at a pace that can feel almost motionless, shifting gently as pressure builds or releases over centuries. This molten rock drifts because of heat from deep within the planet, rising only when it becomes slightly lighter than the surrounding stone. In many cases, magma spends its entire lifetime drifting calmly in the mantle, shaping rock layers from below without ever forcing its way upward. Its movement is patient and deliberate. Like a deep breath, the Earth exhales over thousands of years. The viscosity of magma determines how quickly it can rise toward the surface, acting like a quiet internal governor that controls the speed and style of any eruption. Thin basaltic magma flows smoothly and easily, moving like warm oil through open fractures, while thicker silica-rich magma creeps with heavy resistance, forming sticky chambers that build pressure slowly. These differences create the entire spectrum of volcanic behavior, from gentle lava flows that glide down slopes to powerful explosive eruptions formed by trapped gas. Yet, even in explosive systems, the buildup of viscosity and pressure takes long, calm periods of preparation. Magma's viscosity is like the tempo of the Earth's internal music, setting a rhythm that unfolds on geological timescales rather than human ones. A magma chamber can be vast, stretching beneath the ground like a hidden city made of glowing stone. These subterranean reservoirs store molten rock in quiet darkness, shaped by networks of cracks and pockets that connect like slow-moving streets. Some chambers are shallow, only a few kilometers beneath the surface, while others lie deep within the mantle, evolving slowly as magma enters or cools. Inside, molten rock circulates gently, blending minerals, gases, and heat in patterns that shift over thousands of years. These chambers often remain stable for incredibly long periods, acting as silent archives of the planet's internal activity. They are the Earth's deep reservoirs of potential calm, steady, and massive, shaping the land above through steady warmth rather than sudden force. As magma cools deep underground, minerals begin to crystallize in organized, patient patterns, forming beautiful structures that will one day appear as igneous rock on the surface. Crystals of olivine, pyroxene, feldspar, and quartz slowly grow in the molten mix, sinking or rising depending on their density. This gentle sorting creates layers of rock that tell the story of how the magma cooled, each crystal forming like a quiet, deliberate breath frozen in time. These minerals often lock themselves into place long before the magma ever reaches the surface, preserving the earliest moments of their formation. The slowness of this cooling process gives the Earth some of its most striking natural materials, like granite, gabbro, and obsidian, each shaped through long, patient transformation. Most magma never reaches the surface at all. Instead, it cools slowly beneath the crust, becoming part of the planet's deep interior without creating visible volcanic activity. These hidden magma bodies may rise slightly, shift gently, or spread into thin sheets that solidify silently between older rock layers. Without eruptions, the heat dissipates gradually, allowing the surrounding stone to harden and preserve the shape of the ancient flow. Over millions of years, these frozen intrusions become mountains, cliffs, and underground structures that were once glowing but now rest in complete stillness. This unseen cooling is one of Earth's quietest processes, a reminder that not all volcanic journeys end in fire. Many end in calm. Deep beneath our feet, as magma rises, dissolved gases begin to escape from the molten rock, forming large bubbles that expand slowly within its glowing body. These bubbles grow because pressure decreases the closer magma comes to the surface, allowing gases like water vapor, carbon dioxide, and sulfur dioxide to separate from the melt. Their expansion is not sudden. It happens with the calm patience of warm air rising through thick syrup. In deep chambers, bubbles move upward in slow, gentle motions, shaping the texture of the magma and influencing how it will behave later. Sometimes, these bubbles gather into pockets of gas that widen cracks or create soft internal pressure. Their movement is one of the quietest signals of an approaching eruption. Small, steady, breath-like lifts inside the Earth's glowing interior. Cracks in the Earth's crust often become natural pathways for magma, turning narrow fractures into calm, glowing corridors that guide molten rock upward. These cracks are formed by the slow movement of tectonic plates or by the gentle stretching of the crust as heat builds over time. When magma encounters them, it flows into the openings like warm liquid, following the simplest path, slowly widening the fracture as it travels. Over thousands of years, these cracks can grow into dikes, sills, and networks of underground tunnels that feed volcanoes or remain hidden beneath the landscape. The process is quiet and patient, with magma slipping through stone at a pace that mirrors geological time rather than human time. The color of magma changes depending on the minerals and chemical elements it contains, giving each molten flow its own soft, glowing personality. Iron-rich magma often appears bright orange or red, while silica-rich magma may glow with pale yellow or nearly white intensity when extremely hot. As the magma cools, these colors dim into deeper tones, turning from fiery brightness to dark, crusted surfaces of black, grey, or deep brown. The presence of crystals, gas bubbles, or trace elements can also shift the appearance, creating subtle variations that move across the surface like gentle waves. These color changes are not abrupt. They shift gradually as heat disperses, giving the molten rock a slow, calming transformation that reflects the nature of the Earth's interior. Basaltic magma is thin, fluid, and capable of moving with surprising speed compared to other types of molten rock. It contains relatively low silica, which gives it a low viscosity and allows it to travel in smooth, ribbon-like flows that can stretch for many kilometers. When it reaches the surface, basaltic lava glides down slopes like warm syrup, forming broad fields, long pathways, and gentle, glowing rivers that cool into dark volcanic plains. Even though it moves more quickly than other magmas, its motion still feels calm and steady, following gravity in soft curves rather than abrupt bursts. The ease with which basaltic magma flows makes it one of the most peaceful expressions of volcanic activity on Earth. Felsic magma is thick, dense, and extremely slow to move, behaving more like heavy paste than liquid rock. Its high silica content gives it a stiffness that traps gas and resists flowing through narrow pathways. As a result, felsic magma often rises only a little before settling into deep chambers where it cools very gradually. When it does reach the surface, it tends to erupt explosively because trapped gases cannot escape easily. But even these explosive events are preceded by long periods of waiting, during which the magma gathers heat, pressure, and minerals in complete silence. Felsic magma represents the Earth's most patient, energy-heavy, slow, and shaped by deep, ancient processes that unfold over vast stretches of geological time. Stratovolcanoes are built slowly through countless layers of ash, lava, and volcanic debris, each one added gently over hundreds or thousands of years. Every eruption places a new blanket of material across the slopes, and over time these layers stack like pages in an ancient geological book. The structure grows upward patiently, forming tall, elegant cones with steep sides that tell the story of many quiet rests between moments of activity. Even though people often imagine stratovolcanoes as dramatic, most of their lives are spent in stillness, letting rains soften their slopes and forests grow across their layered surfaces. Their quiet beauty comes not from sudden creation, but from slow accumulation, each layer settling into place, cooling, and becoming part of a mountain shaped by time rather than force. Shield volcanoes form with extremely gentle slopes, spreading out across the land for hundreds of kilometers in wide, soft curves. They are created by thin, fluid lava that flows easily and calmly, spreading like warm oil before cooling. Instead of rising steeply, they expand outward, building vast volcanic landscapes that look almost like ancient, sleeping giants lying beneath the sky. These volcanoes are some of the most peaceful on Earth, erupting quietly and allowing lava to travel great distances without violent bursts. Over time, the repeated flows create enormous, rounded structures, their size so large that you can stand on them without realizing you are on a volcano at all. Their calm shape reflects the peaceful nature of the magma that feeds them. Fissure volcanoes appear as long, narrow cracks in the Earth's surface, releasing lava not from a single mountain but from extended fractures that stretch across the landscape like soft cuts in the crust. When they erupt, lava rises quietly along the entire length of the fissure, creating glowing curtains of molten rock that flow smoothly outward. These eruptions form gentle plains rather than tall peaks, shaping land with wide, even blankets of cooled basalt. Over time, fissure systems can create enormous volcanic fields flat, dark, and textured like waves frozen in stone. Their formation is patient and rhythmic, driven by slow tectonic stretching rather than sudden force. A caldera forms when the land above a magma chamber collapses inward, creating a wide, deep depression shaped by the gentle settling of rock rather than explosive destruction. After an eruption releases enough magma, the roof of the chamber loses support and sinks slowly, often over long periods. The result is a vast, bowl-shaped landscape that can fill with lakes, forests, meadows, or even new volcanic domes. Calderas feel incredibly peaceful, with still waters, quiet winds, and horizons that curve softly around their edges. They are reminders that even large geological changes can create beauty through slow subsidence rather than force. Cinder cones are among the smallest and most delicate volcanic forms, rising only a few dozen meters above the ground, but offering striking, simple beauty. They are built from small fragments of lava called cinders that fall back around a vent and accumulate in gentle slopes. These cones often form in a matter of months or years, but once established, they sit quietly in the landscape, their dark surfaces slowly weathering into soft reds, browns, and blacks. Many cinder cones develop perfectly rounded shapes, like small sleeping hills, and become home to grasses, shrubs, and animals. Their scale makes them approachable and calm, tiny reminders of Earth's volcanic energy expressed in soft, modest forms. Some of the world's largest islands, including the Hawaiian archipelago, were built entirely by volcanoes, rising slowly from the ocean floor over millions of years. Lava from deep-sea vents accumulated layer by layer, cooling and stacking into vast underwater mountains that eventually broke the surface. Once exposed to sunlight and air, these new lands continued to grow as fresh lava flowed across them in gentle sheets, extending coastlines and lifting peaks higher into the sky. Even now, Hawaii remains alive with quiet volcanic activity, its shape still slowly changing as molten rock from below adds new ground. Forests, beaches, and entire ecosystems rest on what began as glowing lava. reminding us that islands can be born not through sudden violence, but through steady, patient creation from deep within the earth. Underwater volcanoes build entire mountains beneath the ocean, forming structures that stretch thousands of meters from the seafloor toward the surface. These volcanoes grow in darkness, their lava cooling instantly as it meets cold seawater, forming rounded pillow-like shapes stacked gently over time. Because the eruptions happen under immense water pressure, they are mostly quiet, releasing their heat in soft plumes rather than explosive bursts. As centuries pass, these submerged mountains rise inch by inch until some eventually break through the waves, becoming new islands. Others remain hidden, serving as foundations for coral reefs and diverse marine life that thrive around their warm, mineral-rich waters. These underwater giants reveal how much of Earth's volcanic world remains unseen beneath the deep ocean. When a volcanic crater fills with water, it forms a deep, serene crater lake with colors that often shift between bright turquoise and rich sapphire. These lakes form when rainwater or groundwater gradually collects in the quiet bowl left behind after an eruption or collapse. Because crater walls are steep and rarely disturbed, the water stays calm and still, reflecting sky and clouds like a natural mirror. Minerals dissolved from volcanic rock can tint the water blue or green, giving each lake its own soft, dreamlike glow. Over time, life often returns around the edges: moss, grasses, and trees growing along the rim, while the lake remains an oasis of deep silence. These crater lakes are some of the most peaceful volcanic landscapes on Earth. Ancient lava flows can solidify into vast basalt plateaus, forming wide, flat landscapes created by eruptions that happened millions of years ago. When thin, fluid lava spreads across the land, it cools into smooth layers that stack upon one another in quiet, even sheets. Over time, these layers can reach enormous thicknesses, creating broad regions of dark, volcanic rock that stretch for hundreds of kilometers. Weathering slowly softens their surfaces, carving gentle hills and winding valleys that still hold the memory of glowing rivers of molten stone. Many basalt plateaus become fertile areas once soil forms above them, supporting forests, farms, and wildlife. These ancient flows reveal how volcanic fire can sculpt entire regions, not through forceful shaping, but through steady, repeated movement across deep geological time. Volcanic ash can compress over centuries into tuff, a soft, porous rock that feels almost like hardened powder. This transformation begins when fine ash from an eruption settles in thick layers, covering the land like a delicate blanket. As more layers accumulate, pressure increases, gently compacting the ash into stone. Minerals within the ash bind the grains together, creating a material that is light, easily carved, and often beautifully textured. Tuff forms cliffs, pillars, and landscapes with smooth, the rounded shapes that look almost sculpted by hand. Its gentle softness comes from its volcanic origin, born not from molten rock, but from the quiet settling of ash through the sky before becoming part of the earth again. Before a volcano shows any dramatic changes, one of the earliest signals is a gentle increase in sulfur dioxide gas, rising softly from cracks around the crater. This gas does not surge violently. It seeps upward like a thin breath, escaping through warm stone. Instruments detect its presence long before humans can sense anything unusual. revealing subtle changes deep within the magma system. As pressure builds far below, dissolved gases begin to separate from the molten rock, creating faint emissions that drift into the air. These early traces of SO2 are like whispers from the Earth's interior, offering clues about shifting magma long before the surface shows any visible signs. The rise is gradual, patient, and almost delicate, marking the quiet beginning of a long geological process. Another soft precursor to volcanic activity is the slow, nearly imperceptible lifting of the ground by just a few millimeters. This gentle swelling happens as magma or gases accumulate beneath the surface, pushing upward with the kind of calm, persistent pressure that only the Earth can maintain. The movement is so slight that it takes sensitive instruments or careful satellite measurements to detect it. Yet this subtle rise spreading across entire valleys, forests, and crater floors reveals that the Earth is stretching quietly from within. Over months or years, these small changes accumulate like the slow inhalation of a deep, ancient breath. Even though nothing dramatic appears on the surface, the land beneath people's feet is shifting in silence, preparing for the next phase of volcanic activity. Heat escaping from below often rises through the ground as thin, delicate vapor, creating faint wisps of steam that drift into the cool air. This moisture is not forceful, it spreads upward gently, forming tiny clouds of white mist around cracks, vents, or warm patches of soil. These subtle emissions come from groundwater heated by magma far beneath the surface, slowly converting to vapor and escaping through fractures. The appearance of these soft steam plumes is one of the clearest, quiet signals a volcano gives: silent, graceful, and almost peaceful. They mark the presence of deep warmth without any sense of urgency, like the Earth exhaling warm breaths into the morning air. The temperature of a crater lake often increases gradually before volcanic activity, warming by just a few degrees over long periods. This warming happens because rising magma or heated gases transfer energy upward, gently increasing the water's heat. The change can be so slow that the lake looks completely undisturbed. Its surface remains still, its color unchanged, its reflections calm. Yet beneath that surface, convection begins to swirl softly, mixing layers of warm and cool water in patterns that shift quietly. Scientists observing these lakes often describe them as breathing, expanding, and contracting with subtle heat for many months before any eruption occurs. It is one of the most serene signs of volcanic unrest. Small, low-frequency tremors often occur before an eruption, but they are so faint that people rarely notice them. These micro-earthquakes are caused by magma moving through narrow passages or gases adjusting within deep chambers, creating tiny vibrations that ripple gently through surrounding rock. Unlike sudden quakes that shake the ground, these signals resemble soft hums or distant thumps detected only by sensitive instruments. They build slowly, forming clusters that grow gradually more frequent, all while remaining calm and almost silent. These tremors are the Earth's quiet language, hinting at internal motion without revealing anything dramatic on the surface. Carbon dioxide can travel upward through tiny cracks in volcanic rock in a way so quiet that it feels almost invisible. This gas does not rush or hiss. Instead, it seeps out gently, like warm breath, drifting through narrow pathways in stone. Because CO2 is heavier than air, it often settles close to the ground, spreading silently across soil or collecting in low areas without disturbing anything around it. Its movement is controlled by slow changes in pressure deep within the Earth, allowing the gas to rise in a steady, patient flow that can last for months or even years before an eruption. Scientists monitor these emissions carefully because even the smallest increase provides a soft clue about shifting magma far below. Yet, in the moment, the release is so calm that nothing on the surface appears to change, making CO2 one of the most delicate and peaceful signals a volcano gives. Small fractures may appear around a volcano as internal pressure gradually increases, but these cracks typically form in a gentle, almost unnoticed way. Rather than producing large breaks or dramatic openings, the Earth creates thin, shallow fissures just wide enough to release tension. They may expand slowly over weeks or months, following natural lines of weakness in the rock while remaining narrow and quiet. Often, these cracks blend into the landscape, hidden among old lava flows, vegetation, and soil. Their formation reflects the Earth's patient method of adjusting to deep internal changes, choosing to stretch slightly instead of tearing suddenly. These subtle fractures can guide gas or steam upward, acting as small pathways that relieve pressure without producing powerful effects. Their quiet appearance is one of the calmest early signs that the ground beneath is shifting. Fine volcanic ash can be lifted into the air long before any strong eruption, drifting upward with a softness that resembles floating dust illuminated by morning light. These tiny particles are so light that even a mild breeze can carry them, spreading them across the landscape in thin, delicate layers. The ash rises slowly, without noise, forming faint hazes that soften the outlines of rocks, trees, and distant hills. Though born from deep heat and molten rock, this early ash behaves like something weightless and gentle, settling onto the environment with barely a touch. It can travel high into the atmosphere or remain hovering close to the ground, moving in graceful currents, shaped entirely by wind. This quiet drifting marks one of the earliest visible signs of unrest. Yet it feels peaceful, like nature painting the air with a soft, volcanic mist. Animals often sense tiny shifts in the earth long before humans notice anything unusual. Many species can detect vibrations far below the threshold of human perception, reacting subtly to changes deep within a volcano. Birds may alter their flight paths or leave an area earlier than expected. Insects might adjust their buzzing patterns, and mammals could move to calmer ground without any clear external reason. These responses arise from instinctive sensitivity, a natural awareness of the planet's gentle tremors that has evolved over thousands of generations. To observers, the behavior may look ordinary, but to the animals, it is a quiet signal that something beneath the earth is stirring. Their movement becomes one of the earliest biological indicators of volcanic change, a whisper from the natural world responding to the soft, deep vibrations of rising magma or shifting gas. The surface color of a crater lake can change gradually as volcanic minerals dissolve into the water, creating hues that shift over time. These transformations are subtle and often peaceful, with no ripples or disturbances breaking the calm surface. Minerals such as sulfur, iron, and silica blend into the water in slow, gentle patterns, influencing how sunlight reflects off the lake. As a result, the water may shift from deep blue to turquoise, jade green, or even opale, milky white. Each color represents a quiet chemical change happening beneath the surface. often driven by increasing warmth or gases rising from below. Observing a lake's color is like watching a living canvas, slowly repainted by the Earth's hidden activity. The shifting hues form one of the most visually soothing signs of volcanic unrest, a calm reminder that even deep geological changes can express themselves softly and beautifully. Basaltic lava moves across the landscape with the smooth, steady flow of warm honey spreading over a surface. Its low viscosity allows it to glide effortlessly, traveling long distances without rushing or splashing. When it emerges from a vent, it forms glowing rivers that move in wide, gentle path, shaping new land with slow, patient motion. Even though it is molten rock, its flow feels calm and almost soothing, following gravity in soft curves instead of abrupt drops. As it spreads, the surface begins to cool into thin, dark crusts that crack quietly as warmer lava slips beneath them. Basaltic flows can continue for hours, days, or even weeks, all while maintaining their tranquil rhythm. Watching one is like watching the earth breathe, exhaling heat in a continuous glowing stream that reveals the planet's inner warmth without violence. Our lava forms rough, jagged blocks on its surface, yet it moves with surprising slowness beneath its broken crust. Though sharp to the touch and rugged in appearance, the motion itself is gentle, creeping forward like a heavy blanket being pushed from behind. The clinking and tumbling of the clinker fragments are soft, almost muffled under the intense heat. Inside, molten lava continues to push forward, maintaining a glowing heart that fuels its gradual advance. Every movement takes effort, as the lava breaks and rebuilds itself inch by inch. The overall effect is one of quiet persistence, a flow that is rough in texture but calm in pace, demonstrating how even the harshest-looking volcanic forms can move with patience and steady determination across the landscape. Pahoho lava flows with a silky smoothness that makes it look almost alive, folding and stretching like ribbons of glowing liquid or soft fabric warmed by fire. As it moves, its surface forms gentle, rope-like patterns that cool into elegant textures unique to this type of lava. Beneath the thin crust, molten rock continues to glide silently, keeping the flow warm, flexible, and beautifully fluid. The movement is hypnotic, slow, deliberate, and entirely graceful. Even though it emerges from deep volcanic heat, when Pahoho spreads, it creates surfaces so smooth they look polished, and the flowing shapes seem to freeze mid-motion as the rock cools. It is one of nature's most serene expressions of molten stone, demonstrating how fire can behave like silk when allowed to move freely. Lava glows in shades of red, orange, and gold because of the intense heat radiating from deep within the molten rock. As temperatures rise, the glow brightens, shifting from deep red to vibrant orange, and sometimes to near-white brilliance at the hottest points. This light is not produced by flames but by thermal radiation, a gentle release of energy that gives lava its fiery appearance. Watching the glow feels like watching the Earth's heartbeat, a warm radiance that pulses softly across the landscape as lava moves. As the surface cools, the color dims slowly, turning from bright orange to deep crimson before fading into dark, solid stone. The gradual change in color mirrors the quiet cooling process, turning intense heat into soothing, fading light that reflects the planet's calm transition from fire to rock. When lava cools, it quickly turns black, as the molten rock solidifies into basalt, forming a crust that darkens rapidly as temperatures drop. This transformation happens quietly, beginning at the surface where the air touches the glowing lava, creating a thin shell that spreads outward like ink drying on warm paper. As more heat escapes, the crust thickens and the color deepens into rich charcoal or glossy obsidian beneath this cooling skin. Molten lava may continue to flow for a long time, moving gently under the dark exterior. The contrast between the glowing interior and the darkened outer shell creates a peaceful rhythm, light fading into shadow, heat softening into stillness. This natural cooling process shows how quickly fire can become stone, leaving behind smooth black surfaces that cradle the last warmth of the Earth's inner energy. Lava can travel for tens of kilometers when it is fluid enough, forming long, glowing pathways that move with gentle persistence across the landscape. These flows often begin at the summit or flank of a volcano and then follow natural slopes, drifting slowly downward like illuminated rivers. Because basaltic lava stays hot for long periods, it maintains its movement far beyond the eruption site, quietly reshaping valleys, fields, and old surfaces it encounters. As it advances, the leading edges cool into dark, rippling crusts, while the molten interior continues to push forward with patient determination. This long-distance travel happens without haste, guided only by gravity and the steady release of internal heat. Over time, these extended flows create wide plains of new rock, covering old ground with fresh layers that will one day become soil, forests, and ecosystems. Watching such a flow, whether in person or through its geological traces, feels like observing the Earth draw new lines across its own surface in slow motion. When lava erupts underwater, it cools so quickly that it forms rounded, pillow-like shapes known as pillow lava. These bulbous structures develop as molten rock meets cold seawater, causing the outer layer to solidify instantly while the inside remains warm and molten. New pillows grow as lava breaks through the cooled skins of older pillows, creating gentle, lumpy formations that stack upon one another, like soft stones shaped by the ocean. The process is completely silent beneath the waves, happening in darkness, where only heat and pressure guide the flow. These lava pillows mark the quiet construction of underwater mountains and ridges, slowly building the seafloor layer by layer. Their smooth, curved shapes show how even fire becomes delicate when surrounded by the cooling embrace of the deep ocean. As lava spreads across the ground, its surface often forms intricate channels and grooves that create natural patterns resembling braided ropes, flowing waves, or carved designs. These lava rills develop when molten rock cools at different speeds, causing the top layer to wrinkle, fold, or crack, while the lava beneath continues to move slowly. The resulting textures look almost artistic, as if the Earth has painted its own patterns across the cooling surface. In some flows, the lines stretch for meters at a time, forming subtle ridges that remain preserved for thousands or even millions of years. Walking across these patterned lava fields feels like stepping through a gallery of nature's slow artwork, frozen evidence of the gentle motion that once shaped the glowing river beneath. As lava cools and contracts, it can fracture into tall, geometric columns of basalt that stand like natural sculptures across the landscape. These columns form when thick lava flows cool evenly from top to bottom, creating tension that breaks the rock into hexagonal or polygonal shapes. The process is slow and silent, with cracks spreading downward in straight lines that segment the cooling lava into towering pillars. Over time, erosion may reveal these columns in cliffs, coastlines, or ancient lava fields, revealing orderly patterns that seem almost too precise to be natural. Yet each column is a product of simple physics: heat fading, rock shrinking, and stress dividing the flow into clean, rhythmic shapes. The result is one of Earth's most impressive quiet creations, born entirely from the patient cooling of molten rock. Lava can eventually create fertile soil as it breaks down over centuries into mineral-rich sediments. Freshly cooled lava begins as hard, dark stone, but exposure to wind, rain, moss, and microorganisms slowly transforms it into fine material capable of supporting plant life. Over long periods, the rough rock weathers into soil full of iron, magnesium, calcium, and other nutrients that help forests, crops, and entire ecosystems grow. Many volcanic regions that were once fields of glowing lava are now home to lush vegetation, farms, and dense forests. The transformation is gradual and gentle: fire turning into earth, stone becoming life. This slow process shows how volcanic landscapes evolve from glowing rivers to some of the most productive and fertile environments on the planet, all through the patient work of time, water, and quiet biological activity. Volcanic ash is incredibly light, often as fine and soft as powdered chalk, drifting through the air with almost no weight at all. When it rises during an eruption, it doesn't fall like heavy dust, but floats gently, carried by the faintest breeze. Each particle is made of tiny fragments of volcanic glass and minerals, so small that they can stay suspended for hours or even days. Despite being born from intense heat, the ash behaves like something delicate, settling across the land in layers so thin they resemble soft grey snow. When ash spreads through the atmosphere, it creates a quiet veil that filters sunlight and softens the world below. This lightweight nature allows volcanic ash to travel far beyond the volcano itself, sometimes crossing entire continents. Its presence high in the sky becomes a silent reminder of the Earth's hidden energy, expressed in the gentlest possible form: fine grains lifted by air, floating like whispers above the landscape. Ash columns rise upward, following warm currents of air that flow from the volcano's vent, creating tall, graceful plumes that stretch into the sky. These towering columns form because hot gases and lighter ash particles lift easily, rising in swirling patterns that resemble soft smoke drifting into higher layers of the atmosphere. Even though the eruption beneath may involve powerful forces, the ascent of ash often looks calm from afar, an elegant vertical motion guided by temperature differences and wind. As the column climbs, the ash spreads outward, forming cloud-like shapes that drift slowly across the horizon. The process can last for minutes or hours, creating a quiet, almost artistic display in the sky. These ash clouds reflect the balance between Earth's heat and the cooling air above, demonstrating how something born from fire can rise with gentleness when lifted by soft thermal currents. Volcanic ash can create beautifully soft red sunsets as light scatters through tiny particles suspended in the atmosphere. When the sun approaches the horizon, its rays must travel through more air, and ash in the sky filters the light in a way that deepens the reds, oranges, and pinks. The effect is gentle, spreading color slowly across the sky like warm paint brushed along the edges of clouds. These sunsets often feel unusually calm and glowing, with hues that linger longer than usual because ash scatters shorter wavelengths of light and allows the deeper tones to dominate. Even though ash comes from intense volcanic activity, the sunsets it produces are some of nature's most peaceful scenes, quiet displays of muted brilliance that soften the end of the day. Observing this transformation, one can see how tiny particles drifting high above can turn the whole sky into a soft canvas of color, reminding us that even the aftermath of fire can become beauty. When ash rises high into the atmosphere, it can scatter sunlight in a way that turns the sky a gentle shade of purple. This transformation happens when fine volcanic particles mix with the natural scattering of blue light, creating a blend that shifts the sky into soft violet tones. The effect is especially noticeable at dawn or dusk, when sunlight travels through a thicker slice of atmosphere and interacts with the suspended ash. The resulting color can be dreamy and surreal pale lavender, muted violet, or even deep amethyst depending on the ash concentration. These skies feel calm and otherworldly, their gentle hues washing over the landscape with quiet stillness. The purple coloration can last for days or weeks after an eruption, serving as a peaceful reminder of the delicate interplay between sunlight and tiny particles drifting through the upper air. It is one of the most serene visual signatures of volcanic influence on the atmosphere. Volcanic ash is composed of ultra-fine mineral fragments, each particle containing tiny crystals and bits of volcanic glass formed during the rapid cooling of magma. These microscopic grains are so small that they can only be seen clearly under magnification. Yet they carry the chemical fingerprint of the volcano that created them. The minerals inside, such as feldspar, quartz, magnetite, or biotite, reflect light in subtle ways, giving ash its muted sparkle when viewed up close. Despite their fiery origins, these particles behave delicately, floating easily on air currents and settling with feather-light gentleness. The ultrafine minerals also influence soil fertility when the ash eventually weathers, releasing nutrients back into the environment. This quiet transformation from tiny airborne crystals to life-supporting minerals shows how even the smallest products of a volcano contribute softly to the Earth's long cycles of renewal. Volcanic ash is so light and fine that it can travel thousands of kilometers from its source, carried gently by strong, upper-level winds that move across continents and oceans. Once ash enters the higher atmosphere, it drifts in long, graceful arcs, spreading thinly across the sky like a delicate veil. Even though it originates from a powerful volcanic event, its journey is remarkably peaceful, gliding through the atmosphere without sound or urgency. Over days or weeks, these particles slowly descend, settling across distant landscapes that may lie far beyond the reach of the volcano itself. This ability to travel such vast distances reveals how connected our planet truly is, how a single volcanic breath can touch distant shores, mountains, fields, and forests. And yet, through all this movement, the ash behaves with the quiet gentleness of dust floating in a sunbeam, a soft traveler in the high winds of the sky. Ashfall can drift downward with the softness of fine snow, settling across the landscape in silent, weightless layers. Unlike heavy debris, volcanic ash falls gently, forming a thin blanket of tiny particles that cover leaves, stones, and rooftops with a muted grey sheen. The descent happens slowly, as if each grain is choosing its place, floating and swirling in the air before coming to rest. When viewed up close, The ash resembles powdered frost or soft winter dust, giving the world a quiet, surreal stillness. Although it originates from molten rock, the manner in which it falls feels peaceful and delicate, almost soothing in its calm descent. The landscape becomes hushed, as if wrapped in a thin veil that dampens sound and softens edges. This gentle fall is one of the most serene expressions of volcanic activity, a moment when fire's remnants drift down like whisper-light snow. When ash spreads through the atmosphere, it can create clouds that sparkle faintly as sunlight scatters through the tiny volcanic particles. Each grain of ash reflects and refracts light in its own way, giving the clouds a subtle shimmer that appears especially close to sunrise or sunset. The effect is delicate, never overly bright, but soft and glimmering, like dusted crystals drifting across a dim sky. These ash-laden clouds often look lighter and more luminous than regular clouds, with edges that glow gently under the sun's low-angle rays. The atmosphere becomes a quiet canvas of soft sparkles, reminding us of the volcanic origins hidden far below. Even though ash is born from fiery molten rock, once it rises into the sky, it participates in this tranquil interplay with light, adding hints of brilliance to the heavens in a way that feels calming and almost magical. Over time, ancient volcanic ash settles and compresses into beautiful sedimentary layers that hold the memory of past eruptions. These layers can appear as delicate bands of pale grey, soft tan, or warm brown within cliffs and rock formations, each representing a moment when fine ash drifted across the land and gently accumulated. As minerals bind the ash together, the layers harden into tough or ash-rich sediment, creating patterns that look almost painted by nature. These deposits are not formed abruptly. They grow slowly as tiny particles settle, compact, and transform over thousands or millions of years. The result is a quiet geological archive, stripes and sheets of ancient volcanic dust preserved in stone. Walking through canyons or cliffs shaped by these layers feels like reading a peaceful chapter of Earth's history, where even past eruptions leave behind beauty rather than violence. Volcanic ash plays a long-term role in enriching soils, helping create some of the most fertile landscapes on Earth. As ash weathers over years and centuries, it breaks down into minerals such as potassium, phosphorus, and trace elements essential for plant growth. This transformation happens slowly as rain, wind, and microorganisms work together to soften and crumble the ash into fine, nutrient-rich sediments. Regions once covered by volcanic deposits eventually blossom with forests, farms, and diverse ecosystems, demonstrating how the remnants of eruptions can nurture life. The process is gradual and gentle, a quiet shift from powdery grey ash to dark, healthy soil. Many of the world's most productive agricultural regions owe their richness to this long, patient conversion. It is a reminder that volcanic activity, though powerful in the moment, contributes to the Earth's renewal through subtle, life-giving changes spread across deep time. Most of Earth's volcanoes are hidden beneath the ocean, forming a vast network of underwater mountains and volcanic ridges that shape the seafloor with quiet persistence. These submarine volcanoes erupt far more frequently than those on land, yet their activity remains unseen in the darkness of deep water. Instead of towering cones or visible lava flows, they create long chains of ridges, gentle slopes, and new oceanic crust that forms slowly as molten rock cools. The deep sea muffles every movement, allowing eruptions to unfold with muted energy, as if wrapped in layers of calm water. This hidden volcanic world covers more than half of the planet's surface, silently building new landscapes in the shadows. Though we rarely witness their activity, these underwater giants play a central role in shaping Earth's geology, continuously renewing the ocean floor in a slow, steady cycle that has persisted for millions of years. The immense pressure of the ocean makes underwater eruptions far quieter and gentler than those that occur on land. At great depths, the weight of the water column suppresses explosive force, preventing gases from expanding rapidly. Instead of violent bursts, molten rock erupts with a muffled push, releasing heat and material in soft, controlled flows. The surrounding water cools the lava immediately, further calming the eruption and turning what could be a dramatic event into a slow, muted exchange between fire and sea. This pressure also shapes the lava into unique forms, allowing it to spread or accumulate without airborne ash or explosive sound. Every stage of the eruption feels softened, as if the ocean's overwhelming weight acts like a thick blanket, quieting the volcano's breath and turning intense energy into gentle, underwater motion. When molten lava meets cold seawater, it transforms instantly into volcanic glass, creating fragments and surfaces that appear smooth, shiny, and brittle. This rapid cooling occurs within moments, as the intense temperature difference forces the outer layer of lava to harden suddenly into a glassy shell. Inside, the rock may still be molten for a short time, but the exterior becomes solid, forming sharp, glittering textures that catch and reflect faint underwater light. This process produces materials like obsidian or hyaloclastite, depending on how the lava fractures or shatters beneath the waves. The transformation is swift, yet peaceful, a quiet meeting between fire and water that creates something entirely new. These glassy structures often accumulate on the sea floor in gentle piles, reminding us that even a violent temperature exchange can result in soft, delicate forms shaped silently in the dark. Gases released during underwater eruptions rise as large, floating bubbles that drift toward the surface in slow, shimmering columns. The pressure at depth compresses these bubbles at first, but as they rise through the water, they expand gradually, forming soft, transparent spheres that move with an almost hypnotic grace. Each bubble carries a mixture of volcanic gases such as carbon dioxide or sulfur that escaped from molten rock beneath the ocean floor. Their ascent is gentle, creating streams of rising globes that look like luminous beads moving upward through the dim water. The journey can take minutes or hours, depending on depth, but the motion remains calm throughout. These bubbles offer one of the few visible signs of underwater volcanic activity, tracing a quiet path from the seafloor to the sunlit surface far above. Deep beneath the ocean, pillow basalt forms when lava cools rapidly under immense pressure, creating rounded, pillow-like structures that stack softly along the seafloor. Each pillow begins when molten rock extrudes from a crack or vent, immediately forming a solid crust as it is chilled by cold seawater. As more lava pushes outward, the crust cracks and new pillows emerge, creating layers of smooth, bulbous formations. Over time, these pillows accumulate in clusters that resemble gentle piles of stone cushions resting in the darkness. Because the cooling happens so quickly, the outer surfaces remain glassy and smooth, while the interior solidifies slowly. pillow basalt landscapes feel serene and ancient, shaped through countless quiet eruptions in places where light never reaches. Coral reefs often grow on the remains of ancient underwater volcanoes, turning once fiery mountains into peaceful ecosystems full of life and color. As volcanic rock weathers in the ocean, it becomes a stable foundation for coral larvae to attach to, slowly forming reefs that spread like delicate gardens across the submerged slopes. Over centuries, these reefs create vibrant habitats filled with fish, sea turtles, and countless marine species, transforming rugged lava into gentle underwater landscapes. The volcano beneath may be long extinct, its heat faded into memory, yet its structure continues to support life in quiet, enduring ways. This transformation from dark, solid basalt to bright coral cities shows how the ocean gently reclaims volcanic shapes and turns them into living sanctuaries. What was once born from fire becomes a cradle for some of the most peaceful ecosystems on Earth. Hydrothermal vents along underwater volcanic ridges release mineral-rich hot water that nurtures unique microorganisms capable of surviving without sunlight. These warm flows seep from cracks in the seafloor, carrying dissolved metals and chemicals that form the base of entire deep-sea ecosystems. The microorganisms use the chemical energy in these fluids to fuel their metabolism, creating a quiet, ancient form of life called chemosynthesis. Around these vents, strange yet peaceful creatures gather: tube worms, clams, and ghost white crabs, living in harmony with the warmth that rises from Earth's interior. Even though the surrounding ocean is cold and dark, the gentle heat provides a sanctuary where life flourishes in slow, steady cycles. These ecosystems reveal how volcanic energy can support life in places where sunlight never reaches, offering a serene glimpse into the hidden resilience of the deep sea. When heat from volcanic activity escapes into the ocean, it can form soft columns of white smoke known as hydrothermal plumes. These plumes are not true smoke, but tiny mineral particles suspended in warm water, drifting upward like pale clouds in the dim light of the deep sea. The minerals carried in the heated water scatter faint light, giving the plumes a soft, milky glow as they rise. Their motion is slow and graceful, shaped by gentle underwater currents rather than forceful bursts. As they ascend, the plumes gradually cool and disperse, settling back into the surrounding water in a calm, swirling dance. These white smokers offer one of the most tranquil signs of volcanic activity beneath the waves, a quiet expression of warmth rising through cold darkness. New islands often begin deep beneath the ocean as underwater volcanoes build layer upon layer of solidified lava. Over thousands of years, repeated eruptions stack rock upon rock, slowly raising a submerged mountain toward the surface. The process is incredibly patient, with each eruption adding only a small amount of material. Eventually, the emerging summit breaks through the waves, forming a young island surrounded by steaming vents and fresh black basalt. At first, the landscape is bare and silent, but over time, winds bring seeds, birds arrive, and life gently takes root in the new volcanic soil. These islands remind us that land itself is born from deep, unseen processes, rising from the ocean in slow to steady breaths. Many underwater volcanoes have never been seen by human eyes, resting in the deep ocean where darkness, pressure, and distance make exploration difficult. These hidden giants erupt silently beneath kilometers of water, shaping the seafloor and influencing ocean chemistry without ever breaking the surface. Scientists know of their existence through seismic signals, temperature changes, and subtle shifts in the seafloor detected by satellites. But the volcanoes themselves remain concealed. Some have been active for millions of years, building vast ridges and underwater mountains that no one has directly observed. Their unseen presence adds mystery to the deep ocean, reminding us that much of Earth's volcanic world remains unexplored, quietly shaping the planet from the shadows. Supervolcano eruptions are among the rarest geological events on Earth, occurring so infrequently that entire civilizations can rise and fall between them. These eruptions require enormous amounts of time to build, with magma accumulating quietly in massive underground chambers over hundreds of thousands of years. Because they erupt so rarely, supervolcanoes spend most of their existence in deep stillness, showing no dramatic signs of their hidden power. Their rarity makes them fascinating. They remind us that the Earth can hold vast reservoirs of energy in complete silence. During their long resting phases, these giants appear no different from calm valleys or broad plateaus, offering forests, lakes, and meadows a peaceful home on their surfaces. The true scale of their dormant strength remains tucked away beneath layers of rock, waiting patiently in the dark. Their infrequent activity highlights the planet's slow rhythms, where even the greatest forces express themselves only after unimaginable spans of time. Yellowstone, one of Earth's best-known supervolcanoes, is currently in a state of deep geological sleep. Its colossal magma system lies far beneath the surface, warming the ground enough to create geysers, hot springs, and steaming vents, yet remaining stable and quiet across human timescales. The region's bubbling pools and colourful mineral terraces are gentle reminders of the heat below, but they signal long-term calm rather than imminent activity. For thousands of years, Yellowstone has shifted, breathed, and released small amounts of energy through hydrothermal features, all while maintaining a peaceful balance in its enormous magma chamber. Scientists observe subtle ground movements and gas emissions, but these are part of Yellowstone's natural resting cycle. In this deep slumber, the supervolcano embodies the patience of geological time, vast, steady, and unhurried, its true power resting silently beneath forests and open sky. A supervolcano caldera forms through an incredibly slow and gradual process, shaped by the settling of land after enormous volumes of magma have been released. These calderas are not created through sudden collapse alone, but through long-term subsidence as the Earth adjusts to the emptied chamber below. The result is a massive, often circular depression stretching tens of kilometers across, filled over time with lakes, forests, meadows, and gentle slopes. From the ground, the caldera may feel like an ordinary valley or broad basin, its vast scale so subtle that visitors often do not realize they are standing inside the remains of an ancient eruption. The formation is peaceful once the initial activity ends, with the landscape slowly softening as erosion, vegetation, and water reshape the terrain. These quiet plains and rolling hills are the Earth's way of healing after a major event, turning the remnants of one of nature's largest forces into serene, expansive spaces. Pressure inside a supervolcano increases not over weeks or months, but over thousands of years as magma slowly accumulates beneath the crust. This buildup is incredibly gradual, driven by deep mantle processes that move with the calm patience of geological time. As new magma enters the chamber, gaz dissolve, pockets shift, and heat spreads through surrounding rock. The land above may rise by only a few millimeters each year, so subtle that it can be detected only with precise instruments. Over centuries, these tiny changes add up, creating a gentle swelling of the ground that reflects the slow gathering of energy far below. This long-term pressurization is like a deep inhalation, stretching across vast periods and almost impossible for humans to perceive. It demonstrates how the planet's largest forces operate with extraordinary slowness, building pressure in a quiet, deliberate rhythm that spans generations. Ash from a supervolcano eruption can travel across entire continents, carried by powerful atmospheric currents that distribute fine particles far beyond the eruption site. Because supervolcanoes release immense volumes of ash into the upper atmosphere, the particles can remain suspended for long periods, drifting like soft, grey waves over distant lands. The ashfall may be gentle, settling quietly on forests, mountains, rivers, and plains thousands of kilometers away. Even regions far from the volcano can experience dimmed sunlight, muted whiz, or hazy horizons as the ash disperses. Though the eruption itself may be intense, the movement of ash afterward occurs with a soft, almost dreamlike quality, tiny grains floating through the air, drifting slowly downward in a calm, continuous fall. These widespread deposits eventually become part of the geological record, forming layered archives that preserve the memory of ancient supervolcano events in delicate, expansive sheets. Deep magma reservoirs beneath supervolcanoes are enormous, often stretching for dozens of kilometers in length and several kilometers in depth. These vast chambers hold partially molten rock mixed with crystals and gases, forming a warm, slowly shifting body that behaves more like a thick, glowing ocean than a simple pool of lava. The magma does not churn violently. Instead, it moves in slow convection currents, rising and sinking over centuries as heat circulates quietly through the chamber. These deep reservoirs change gradually, shaped by processes occurring far below the reach of human senses. Their immense size allows them to store energy for thousands of years before any eruption occurs, which is why supervolcanoes spend most of their existence in peaceful dormancy. The calm, steady presence of these magma bodies beneath the crust is one of the Earth's most silent geological features. Hidden from view yet essential to the planet's long-term evolution, beneath the surface of supervolcanoes, enormous fractures can extend for many kilometers, forming deep, elongated cracks that guide heat, fluids, and molten rock through the crust. These fissures are not dramatic, explosive breaks, but slow-growing structures shaped by gentle stretching and rising pressure over centuries. They serve as quiet pathways, allowing gases to escape and magma to redistribute far below the ground. These fractures often remain completely hidden from the surface, detectable only through seismic imaging or subtle patterns of ground movement. They can weave like geological threads through layers of rock, sometimes branching or merging as the crust responds to long-term shifts. Their existence reflects the Earth's ability to adjust slowly, creating delicate structural changes that prepare the entire volcanic system for future evolution. Even though they form on immense scales, these fissures grow with quiet patience, mirroring the slow heartbeat of the supervolcano they support. A magma chamber within a supervolcano behaves much like a vast, liquid sea hidden beneath the crust. Within this molten body, currents rise and fall gently as heat transfers through different layers, creating a slow-motion circulation that can last for thousands of years. Crystals form, melt, or settle depending on temperature and pressure, drifting through the glowing melt like soft sediments in deep water. The surface of this magma sea is not flat, but shifts subtly as composition and heat levels change. Over immense spans of time, the chamber breathes, quietly expanding slightly as new magma enters, contracting as material cools or crystallizes. This ocean of molten rock is one of the Earth's calmest yet most powerful features, existing in a state of perpetual, slow transformation. It is a reminder that even beneath solid ground, the planet's interior moves with fluid grace, shaping the world above without sound. Temperature beneath a supervolcano increases with extreme slowness, often rising just a fraction of a degree over many years or even centuries. This gentle warming occurs as new magma seeps gradually into the chamber, or as heat slowly accumulates through natural radioactive decay deep underground. Because the crust insulates so effectively, even tiny temperature changes require enormous amounts of time. These subtle shifts often go unnoticed at the surface, affecting only the deepest layers of rock surrounding the magma reservoir. But they are meaningful. Small increases can influence the behavior of crystals, the pressure of dissolved gases, and the overall balance of the magma system. This slow warming reflects the calm, deliberate nature of geological processes tied to supervolcanoes. Instead of rapid spikes, the system evolves in soft, almost imperceptible stages, its long timeline stretching far beyond human perception. Evidence of ancient supervolcano eruptions remains etched in old rock layers, preserving the quiet memory of events that happened millions of years ago. These traces appear as thick sheets of volcanic ash, welded tough, crystal-rich ignimbrita, or widespread deposits that stretch across entire regions. Over time, erosion, weathering, and sedimentation soften their edges, blending them gently into surrounding landscapes. Though the eruptions themselves were immense, the remnants now feel peaceful, layered rock formations that tell a story through subtle patterns and mineral signatures. Geologists study these formations to understand cycles of past activity, reading them like pages from an ancient, silent record of Earth's deep history. These traces remind us that even the planet's most powerful events eventually settle into quiet stillness, leaving behind serene landscapes shaped by time rather than destruction. When lava cools after an eruption, it slowly transforms into a brand new plain, spreading across the landscape like a dark, silent sheet. The cooling process can take weeks, months, or even years depending on the thickness of the flow. But over time, the rough surface begins to settle into gentle shapes. Cracks form as the rock contracts, creating natural pathways for future water and plant life. These newborn plains eventually weather into soils that support pioneering mosses and hardy grasses, which start the quiet process of turning solid rock into living ground. Although the lava may have arrived with heat and fire, its aftermath is almost completely silent, leaving behind sweeping landscapes that look as though they were placed there by slow, omniscient hands. These plains are reminders of how the Earth renews itself, forming new foundations where life will one day return and flourish. Volcanic ash, despite its dramatic origins, is remarkably rich in minerals that encourage new plant growth. Once the ash settles, it begins breaking down into fine particles that blend with existing soil, delivering nutrients like potassium, phosphorus, and trace elements essential for vegetation. This mineral infusion allows plants to return surprisingly quickly after an eruption, often creating vibrant green landscapes within just a few years. Early colonizers such as ferns and shrubs spread across the ash-covered ground, slowly stabilizing the soil and preparing it for forests and larger ecosystems. What began as a grey, silent layer becomes a fertile foundation, capable of supporting a diverse array of plant life. This transformation highlights the gentle resilience of nature, showing how the earth turns moments of destruction into quiet beginnings, with new life rising softly from the remains of fire. Heat lingering from underground magma systems can create hot springs long after an eruption has ended. These warm pools form when groundwater seeps deep into heated rock layers, absorbs warmth, and slowly rises back to the surface. The water often emerges gently, producing steady streams or calm basins of mineral-rich liquid. Many hot springs appear tranquil, with steam drifting upward in thin, pale ribbons that blend with the surrounding air. The warmth they carry is a soft reminder of the volcanic energy still present beneath the earth. Even during times of deep geologic rest, over centuries, layers of minerals can accumulate around these springs, forming smooth terraces or colorful deposits that add beauty to volcanic landscapes. Hot springs show how the Earth's inner heat can express itself not through violence, but through peaceful, steady warmth that radiates quietly through the land. Fumaroles are some of the softest and gentlest expressions of volcanic activity, releasing thin wisps of steam that drift into the air almost silently. These vents form when heat from deep magma warms underground water, transforming it into vapor that escapes through small cracks in the rock. The rising steam often appears as delicate clouds hovering above the ground, sometimes carrying faint traces of minerals that give it subtle colors or soft shimmering effects. Unlike eruptions or lava flows, fumaroles are extremely quiet. Their presence felt more through temperature and moisture than sound or motion. Their gentle exhalations can continue for decades or even centuries as long as enough heat remains below the surface. In many volcanic regions, fumaroles add to the dreamy atmosphere, creating scenes where mist and earth blend into one calm breath, offering a peaceful reminder that even active geological systems can move with incredible softness and patience. Ancient volcanic regions can eventually turn into fossilized landscapes, forming striking rock formations that preserve the shapes of long-extinct eruptions. Over millions of years, lava flows, ash deposits, and volcanic debris harden into stone, which erosion later sculpts into pillars, cliffs, and layered patterns. These fossilized terrains often display beautiful colors, from deep reds to soft grays and warm browns. Depending on the minerals contained in the original lava and ash, their textures tell silent stories of past eruptions, recording how fire once shaped the terrain before cooling into stillness. Walking through these landscapes feels like moving through time itself, where the memory of ancient volcanic activity remains frozen in rock. Despite their fiery origins, these formations now stand in quiet, enduring beauty, softened by wind, rain, and vegetation. They remind us that even the most powerful natural forces eventually become calm, stable, and deeply peaceful parts of the Earth's surface. Lava tubes form when the surface of a flowing lava river cools and solidifies while molten rock continues moving beneath it. Over time, the internal flow drains away, leaving behind a hollow tunnel that can stretch for kilometers beneath the ground. These tubes become quiet, corridors shaped by heat, darkness, and slow geological patience. Inside, the air feels still, and the rocky walls often show ripples frozen in place from the once flowing lava. Some tubes contain small skylights where parts of the ceiling collapsed, letting soft beams of light enter the darkness. Others remain perfectly preserved, silent and untouched for thousands of years. These tunnels provide habitats for specialized organisms, store geological history, and reveal how lava once moved with steady determination. Walking through one feels like stepping inside the Earth's ancient breath, where the memory of volcanic fire remains suspended in unmoving stone. Caldera lake basins are some of the quietest volcanic landscapes, formed after the center of a volcano collapses and later fills with water. These lakes often rest in enormous circular depressions surrounded by steep, serene cliffs that mirror gently on their surfaces. The water is typically deep and still, reflecting sky, clouds, and distant ridgelines in flawless calm. Because calderas form from slow geological processes long after eruptions end, the lakes feel like peaceful scars, delicate, reflective, and undisturbed. Temperature changes occur gradually, with morning mist rising softly from the surface and evening winds brushing across the water in faint ripples. Many caldera lakes host unique ecosystems, their quiet isolation allowing rare plants and animals to thrive. To visitors, these basins appear timeless, like vast bowls of tranquility resting at the heart of ancient volcanic worlds. Obsidian forms when lava cools so rapidly that crystals cannot grow, creating a natural volcanic glass with a deep black sheen. Its surface is smooth and reflective, often catching light in subtle glimmers that resemble polished stone or dark, still water. When fractured, obsidian breaks with sharp, curved edges known as conchoidal fractures, revealing swirling patterns locked within the glass. Despite its fiery origin, obsidian has a cool, almost silent presence, lying in glossy patches across volcanic fields or embedded in weathered cliffs. For thousands of years, humans valued obsidian for its sharpness and beauty, shaping it into tools, ornaments, and ceremonial objects. In volcanic landscapes, these glistening stones scatter across the ground like remnants of frozen fire, adding an ancient elegance to the terrain. Their dark reflections create a soft visual contrast against ash, basalt, and weathered rock, making obsidian one of the most striking yet quietly understated products of volcanic activity. Volcanic landscapes carry an ancient atmosphere, shaped by countless cycles of eruption, erosion, and renewal. Jagged ridges, old lava plains, ash-covered valleys, and weathered basalt cliffs tell stories that stretch back millions of years. These terrains often feel untouched by time, holding on to primitive shapes that predate forests, rivers, and even many forms of life. Wind and rain sculpt them slowly, smoothing rough textures and carving gentle curves into hardened lava. Mosses, lichens, and tough pioneer plants gradually settle into cracks, adding hints of green to an otherwise elemental world. The air in these places often feels still and vast, as though the land itself remembers the deep history of Earth's formation. Walking through such scenery evokes a sense of returning to a more ancient planet, one where fire shaped the ground and silence reclaimed it afterward. In their quiet endurance, volcanic landscapes reflect the oldest rhythms of geology. Dormant volcanic craters become places of deep stillness, their once fiery mouths softened by time, weather, and new life. After an eruption cycle ends, the crater gradually fills with sediment, vegetation, or even small lakes, transforming into a calm, circular sanctuary. The slopes that once funneled lava now hold grasses, shrubs, and forests growing in layered rings. Wildlife often returns quickly, finding shelter in the sheltered basin and stability in the fertile volcanic soil. Wind moves gently across the crater floor, and echoes soften against the curved walls, creating a sense of natural quiet that feels almost sacred. These sleeping craters act as reminders of ancient forces now resting beneath layers of calm earth. They embody the long pause in a volcano's life, a peaceful interval that can last thousands or even hundreds of thousands of years, leaving behind landscapes where silence feels deep and enduring. Earth is still cooling very slowly from its fiery beginnings more than 4 billion years ago. The planet formed through intense heat, collisions, and molten oceans of rock, and although the surface has hardened, the deep interior continues to release warmth at a gentle, steady pace. This slow cooling drives geological processes such as convection in the mantle, the drift of continents, and the movement of magma far below the crust. The rate is so gradual that human civilizations span only a brief moment in Earth's long cooling timeline. Even now, volcanic heat, geothermal springs, and the soft rise of warm gases bear witness to the warmth still lingering within the planet. This gradual loss of heat is part of Earth's natural rhythm, a quiet pulse that shapes mountains, oceans, and landscapes across millions of years. It reminds us that beneath its forests and cities, Earth remains a living, breathing world shaped by slow, ancient fire. Tectonic plates drift across Earth's surface with the calm, steady motion of wooden rafts floating on a deep, slow-moving current. These plates move only a few centimeters each year, far slower than fingernails grow yet over millions of years. Their gentle motion rearranges continents, opens and closes oceans, and builds mountain ranges. The boundaries between plates are places where earthquakes, volcanoes, and new crust form, but the movement itself is incredibly quiet and patient. Although we often imagine dramatic collisions, the plates slide past each other or converge at a pace so gradual that the change is imperceptible in a human lifetime. Their drifting is part of Earth's deep time cycle, an elegant rebalancing that ensures the surface remains dynamic rather than static. This slow continental journey reveals a world where even the largest features oceans, mountains, islands are shaped by processes moving in near silence, guided by the gentle flow of Earth's mantle below. Volcanoes play a vital role in renewing Earth's surface, creating new land through the slow accumulation of lava, ash, and minerals. When molten rock reaches the surface and cools, it solidifies into fresh crust that becomes the foundation for future landscapes. Over time, these new formations weather into soil, support plant life, and become part of ecosystems that flourish atop once fiery ground. Islands like Hawaii, Iceland, and countless seamounts began as volcanic eruptions, demonstrating how life often emerges from places shaped by fire. Even on continents, lava flows, widen plains, fill valleys, and create new terrain that slowly transforms under wind and rain. This ongoing resurfacing is subtle, measured not in years but in centuries and millennia, reshaping Earth with quiet determination. Volcanoes remind us that destruction and creation often coexist, with each eruption paving the way for renewal and growth in its calm aftermath. Earth releases steam, gases, and heat through billions of tiny fractures that spread across the crust like delicate veins. These microevents are far too small to notice individually, yet together they form a global network of subtle exhalations. Steam rises from volcanic fields, mineral springs, forest floors, and regions where groundwater meets warm rock. This gentle release of Earth's inner breath helps regulate pressure deep below the surface, allowing the planet to maintain a stable crust. Most of these vents emit only faint wisps of gas, sometimes visible only in cold morning air or in the thin shimmer of heat above warm soil. They represent one of the quietest expressions of Earth's internal processes, soft, steady, and nearly invisible. Through them, heat escapes slowly into the atmosphere, reminding us that the ground beneath us is not static but alive with subtle motion and energy. The Pacific Ring of Fire, the vast arc of tectonic boundaries circling the ocean, moves far more slowly than most people imagine. Though it is home to many active volcanoes and deep ocean trenches, its overall motion is measured in slow, patient millimeters per year over immense spans of time. These movements reshape coastlines, raise mountain range, and deepen trenches. Yet in a human lifetime, the Ring of Fire seems almost still. The plates involved shift with quiet persistence. Guided by mantle currents deep beneath the ocean, earthquakes and eruptions may punctuate the cycle, but the underlying drift remains calm and continuous. This enormous system reflects the planet's long-term geological breathing, where immense structures shift just enough to release pressure and maintain balance. Despite its dramatic name, the Ring of Fire is shaped more by slow, steady motion than by violent change, reminding us that the Earth's greatest forces often work in silence. Deep beneath the surface, hot rock moves with the slow consistency of a thick gel, shifting over centuries in smooth, deliberate currents. This semi-molten material isn't fully liquid, nor is it solid. Instead, it behaves like a warm, pliable substance that responds gently to pressure and heat. As it rises and cools, it reshapes the crust in ways almost impossible to perceive from above. These subtle movements help drive tectonic drift, volcanic renewal, and the quiet reshaping of continents. The gel-like flow of this deep rock is a reminder of Earth's hidden softness, its interior moving with a steady rhythm that supports the entire planet from below. Though invisible to us, this slow motion is as constant as a heartbeat, guiding geological cycles that unfold over millions of years. Every volcano on Earth follows a long, natural cycle of rest that far outweighs its active periods. Most volcanoes spend thousands, even tens of thousands of years in quiet dormancy, with no eruptions, nor rumbling, and no outward signs of activity. During these long resting phases, The volcano becomes part of the landscape, its slopes gathering forest, its valleys filling with soil, its crater settling into stillness. Magma chambers recharge at an extremely slow pace, with heat rising gently through the crust, but rarely reaching the surface. These long intervals of peace remind us that volcanic systems operate on timescales far beyond human experience. A volcano's silence is not emptiness, but patience, an ancient pause embedded in the Earth's rhythm. Old volcanic hills gradually transform into forests as time, weather, and life soften their once rugged slopes. Lava flows and ash deposits break down into mineral-rich soil, providing fertile ground for pioneering plants. Mosses cling to cooled rock, shrubs take root in cracks, and eventually trees rise across the slopes, turning former volcanic cones into green sanctuaries. Over thousands of years, wildlife fills the area, creating ecosystems that thrive atop ancient fire. These forested hills often appear peaceful and timeless, their volcanic origins hidden beneath layers of vegetation. The transformation from fiery past to quiet woodland is one of Earth's most gentle transitions, showing how destruction can evolve into new life. What was once a symbol of heat and eruption becomes a place of shade, stillness, and soft-breathing forests. Ancient volcanic ash lies quietly within layers of soil, preserved as soft, parlor bands between darker sediments. These ash layers were once airborne clouds drifting across landscapes, but after settling, they became part of the Earth's memory, pressed gently by centuries of rain, roots, and shifting ground. Over time, the ash particles break down into rich minerals that blend into the soil, supporting plant life and shaping ecosystems. In many places, these layers remain visible in road cuts, canyon walls, or riverbanks, revealing delicate patterns that mark long-forgotten eruptions. Though the eruptions themselves may have been powerful, the ash now rests in complete stillness, offering a quiet geological record of Earth's ancient breath. These soft layers tell stories without sound, stories of fire, sky, and the slow settling of time. Heat from Earth's interior plays a gentle but essential role in supporting life across the planet. This internal warmth drives geothermal springs, stabilizes ocean temperatures near hydrothermal vents, and even influences climate by helping maintain the movement of tectonic plates. In the deep ocean, entire ecosystems depend on this heat, gathering around warm vents where life thrives without sunlight. On land, geothermal energy nurtures hot springs, warms groundwater, and subtly affects soil temperatures, creating environments where plants and animals can flourish even in cold regions. Although we rarely feel this heat directly, it rises softly through the crust, contributing to the warmth that sustains life. Earth's internal fire is ancient and quiet, a steady source of energy that has supported living organisms since the planet first cooled. It is a reminder that warmth can come not only from the sun above, but from the deep comfort of the planet below. As this journey through the quiet world of volcanoes comes to a close, let every detail settle gently around you, like warm ash drifting down after a distant eruption. You've walked through places shaped by fire but softened by time, lava plains now covered in green, caldera lakes resting inside ancient scars, tunnels once filled with molten rock now standing silent beneath the earth. These landscapes remind us that even the most powerful forces eventually slow, cool, and fold themselves into stillness. What begins with heat ends with calm. What rises with force settles into quiet. You've moved through the deep chambers beneath the crust, where magma flows with the patience of centuries. Down there, the earth breathes at a rhythm so slow that it feels almost timeless, a gentle push, a circulation, a soft release of heat. Every volcano you've imagined tonight carries that same hidden heartbeat, pulsing beneath forests, plains, oceans, and mountains. It's a reminder that even in a world of great change, there are currents beneath us that move steadily and without hurry. Above ground, the story is just as peaceful. Lava that once glowed like a river of stars eventually cools into rock that cradles new life. Ash that once drifted across the sky settles into soil that grows forests. Even the steaming vents, the warm springs, the mineral pools, each one is the earth whispering, "I am here, I am alive, and I move slowly." These gentle signals form a soft language of heat and stone, spoken in breaths of steam and quiet shifts of land. And then there are the sleeping giants, the volcanoes that rest longer than civilizations. Their slopes become forests, their craters become lakes, and their old lava flows become paths where animals wander through morning fog. Nothing in nature hurries them. They simply wait in the deep time of the planet. Their stories layered like the rock beneath your feet. Tonight, they've invited you to rest in that same ancient stillness, to let go of the pace of your day, to feel the calm that comes from knowing some things move slowly enough that we can trust them. Even the smallest details we explored, the way heat rises from hidden vents, the way obsidian catches light, the way ash settles into the earth, each one carries the same gentle truth. The earth reshapes itself calmly. Fire and silence belong to the same world. They are not opposites, but phases. One begins, the other completes. One erupts, the other heals. As your mind drifts, imagine the planet settling into its own night. Far below, the interior glows softly like embers in a long burning fire, warm enough to nurture life, but quiet enough to let everything above rest. On the surface, forests breathe, rivers move, winds settle, and the sky folds into darkness. The volcanoes, those ancient storytellers, lie still, holding the memory of the Earth's earliest days while offering peace in the present. Let yourself settle into that same rhythm. A slow inhale, a long, gentle exhale, like the rise and fall of heat beneath the crust, like the cooling of lava into solid ground, like steam drifting into the morning air. Your breath is part of the same cycle of calm that moves through every layer of this planet. If your mind wanders, imagine standing at the edge of a quiet caldera lake. The water is still, the air is warm, the world is quiet. Everything around you has been shaped by fire, but in this moment, nothing burns. Everything rests. Everything breathes. Thank you for sharing this quiet space. And whenever you return, whether in daylight or darkness, the Earth's slow, ancient calm will be here, waiting for you. Good night, and rest deeply.